Here, we'll demonstrate a typical data exploration process in ManiVault, as discussed in the second application example, which focuses on practitioners. We will load a dataset, inspect it in several views, perform a HSNE analysis, and share a parameter between two views. First, we load our dataset of interest. We can either open a loader through the context menu on the data hierarchy or through the File menu tab on top of the application window. I already navigated to the folder that contains the high-dimensional image that we want to load. Similar to the data loader, we can open views through context menus attached to the data, which will immediately populate the viewer with the data, or we can open an empty viewer through the View menu tab. In the image viewer, we can display any image channel of interest. For now, we'll select this channel and display it as a grayscale image. Next, we open another view on the data, the Spectral View plugin. This view shows all dimension values for a single point or the average value per dimension for a selection of data points. Whenever we make a selection in the image viewer, the spectral viewer updates accordingly. For flexible selection definitions, we provide several interaction modes. Now, to gain some better overview of the high-dimensional data space, we open a HSNE Analytics plugin. Since we did not start the computation yet, the output dataset will only be populated with 0 initialized data. Before starting the computation, we can adjust the settings appropriately. The embedding computation takes some seconds, but we can speed this waiting time up a little in this video. Any data updates that an analytics plugin publishes to the core will be sent to all plugins that listen to such update notifications. Hence, the scatterplot shows the entire embedding optimization process in real time. The selections we make in this derived dataset are propagated to its parent data and all linked datasets, as can be seen in the image viewer and spectral viewer. We are now manually defining clusters in the embedding, corresponding to some apparent structures, like buildings, vegetation, and water. We could, of course, also automatically cluster the embedding using another analytics plugin. Now, let's inspect the average spectra of our clusters in the spectral viewer. The most interesting one seems to be the cluster corresponding to buildings. The HSNE plugin added an action to the embedding that is accessible through a context menu in the scatterplot. We can refine the embedding for a given selection and explore this selection on a more detailed level. Just like with the top-level embedding, the new HSNE scale is connected to the main dataset and selections are propagated accordingly. We can change some visual properties of the scatterplot, like point size or the color map. To better connect the image layout with this embedding, we now want to display the color of each point in the embedding at their corresponding pixel position in the image. To do this, we can simply drag the embedding dataset to the image viewer. The image viewer will deduce the image dimensions from the image dataset present in the data hierarchy and create a new layer. For now, the color maps in the scatterplot and image viewer are not the same though. We can link these two GUI elements since they were created with the ManiVault action system. It is possible to adjust which actions are publishable and connectable for each plugin. Actions can of course also be both publishable and connectable as well. When editing these settings, the affected action is underlined when they are exposed to the parameter sharing system. Here, we enable the color map of the scatterplot to be publishable and the color map of the image viewer to be connectable. We cannot connect this color map yet, since no action of a similar type was published. Once we take care of that, we finish the connection and the color map in both views will be synchronized. Zooming into a region of interest in the image, we can now easily distinguish between different types of structures and characterize them with respect to their high-dimensional attributes. A more fine-grained selection of data points is easily possible with the selection tools in the scatterplot and image viewer. At this point, we might be interested in saving this project, which stores the entire application state, that is, the loaded datasets, views, and connections, in order to resume the exploration later. Or we could even choose to publish the setup, which saves the state of the application in the same way, but disables further setting adjustment when opening the project again.